This is Honors Algebra 2 Pre-Calculus. We're doing section 9.1 from Pre-Calc, which is sequences and series. So an explicit formula for the nth term, a sub n, means that you can plug in n, whatever n is, to find a sub n for any n. So as an example of that, if I gave you that a sub n was 2n minus 15, and I wanted a sub 8, I would just plug in n equals 8. I'd get that a sub 8 is 2 times n, which is an 8, minus a 15. So I get 16 minus 15, so a sub 8 is 1. All right, so again, an explicit formula means that if I wanted a sub 100, I could plug in n as 100 and get an answer. If I wanted a sub 1000 or a 1000, I could plug in n as 1000 and get an answer. I don't need any of the earlier terms. So if I just asked you what is the 1000th term, you could just plug in and get that value. So that's what it means to be an explicit formula. A sub n is written in terms of n. So I could plug in any n. So let's walk through an example of that, right? So we're going to go ahead and do an example 1. I'm going to give you, we're going to find a couple of series, or rather sequences by writing out some terms. Okay, so in example 1, right, you're going to be given an explicit formula, right? So we're going to be given an explicit formula for a sub n, and what we're going to do is we're going to write the first 5 terms of the sequence, okay? So again, we're going to write the first 5 terms of a sequence. So the formula that I'm going to give you is I'm going to give you that a sub n equals, so we'll actually call this a, we'll do a couple of these. I'll give you that a sub n equals a negative 3n plus 1, okay? And then we're also going to do, and I'll call this one b sub n just because it's a different sequence, right? I'm going to do negative 2 to the n, okay? So let's walk through each of these. So let's start with a. So since I want the first 5 terms, what that means is I'm going to plug in n as 1, comma, whatever happens when I plug in n is 2, comma, whatever happens when I plug in n is 3, comma, whatever happens when I plug in n is 4, comma, and then my last one is whatever happens when I plug in n is 5, and then dot, 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 because I'm only finding the first 5, but there are others, right? So if I plug n as 1 in here, right, I'm going to get a negative 3 times 1, which is a negative 3, plus 1, so I get a negative 2, right? If I plug in n is 2, I'm going to get negative 3 times 2. So again, the calculation that led to this was a negative 3 times a 1 plus a 1, right? That's how I got the negative 2. When I plug in n is 2, it's going to be negative 3 times 2 plus the 1. So that's a negative 6 plus a 1, which should be a negative 5, right? When I plug in n is 3, I'm going to get negative 3 times 3 plus a 1. Well, that's a negative 9 plus a 1, so that's a negative 8, right? When I plug in 4, I'll get negative 3 times 4 plus a 1. Well, that's negative 12 plus a 1, so negative 11, right? And when I plug in n is 5, I'm going to get negative 3 times 5 plus a 1, so that should be a negative 14, dot, dot, dot. So those are my first 5 terms in my sequence, right? I found the first 5 terms by plugging in n is 1, n is 2, n is 3, n is 4, and n is 5, because it said the first 5 terms. If we do the same thing with my b sequence, right, my b sub n, again, I'm going to start by n is 1, and then n is 2, and then n is 3, and n is 4, and 5. So if I start when n is 1, this would be a negative 2 to the first, right? My next term would be a negative 2 to the second. My next term would be a negative 2 to the third. My next term would be a negative 2 quantity to the fourth. And my last term would be a negative 2 quantity to the fifth, dot, 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 right? If I clean those up, a negative 2 to the first is just a negative 2. A negative 2 squared is a positive 4. A negative 2 to the third is a negative 8. A negative 2 to the fourth would be a positive 16, and a negative 2 to the fifth would be a negative 32, dot, dot, dot. Okay, so there's the first 5 terms in my sequence given an explicit formula.